Alright, let's do this. Alright, hello, everybody. Hello. How's everybody doing tonight? I hope everybody is doing well. I hope we're doing absolutely well. Welcome back. Hopefully you guys are absolutely ready for another rip-roaring session of Math 102 question mark. We'll see how well it goes, I guess. Hopefully it'll go well. How we doing tonight? Hopefully you guys got good plans for the weekend and whatnot. So we'll get started here in just a few minutes. We'll wait for a few more people to come on in, and then we will get moving here with the newest material. For those of you who came in here a bit early, just don't forget that the test and for chapters 5 to 7 and the homework is due next Thursday at 11:59 p.m. So be sure to finish it up before then.
Just begun. We will always take a stand for the people, for the land.
All right.
Let's go back to when we were young.
Meanwhile, while that's happening, nobody's here, or since people are here, I just haven't heard from anyone. Hey Anna, how are you? I'm doing great. How are you? I hope you're having a good day so far. Don't mind me, I'm just kind of sitting here. I'm very lonely. So sad. You good? Okay, that's good. Any plans for the weekend? Unless you plan to go it's getting closer to the end of summer. You know, we're getting deep into fall time, so maybe some people got some last minute plans. They go last minute camping, or they do something outdoors. I don't know if you got that going on this weekend, or pumpkin patch. Yes, see, now it's outdoor activity. Pumpkin patch with the fam. There you go. Getting ready for the end of the fall. Have a nice time with the fam. Go to the pumpkin patch, or that's another good one. The corn maze. Yeah, the corn maze is also really good too. Corn maze is actually pretty good as well. Does your family select a pretty big pumpkin every year? Or do you get pumpkins? I guess is the question. Do you get multiple pumpkins, or do you get a one really big one? They all pick different sizes. Okay, well, that's good. Get to carve them out, have a nice time with the jack-o'-lantern. Or eat them, whichever one you do. Make some pumpkin pie, pumpkin spice, like from Starbucks or something. Yeah, wait, you're stuck carving them. Wait a second here. How are you stuck? You mean only you carve them? You mean nobody else in your family carves them except for you? So they shove all the work to you? Well, Is that what happens? I mean, I love the pumpkin seeds. That's good. I won't deny the pumpkin seeds are great. Well, if you're stuck carving all of them, then, do you like carving them, though? They get frustrated. It's not that hard to do a jack-o'-lantern. You could do a standard one. Yeah, just do like, you know, 2 triangles, you know? A bunch of triangles for the face, a triangle for the nose. Like, it's super easy. You just cut one at a time. I like the end results. They like the intricate ones with the super thin lines. But look, this isn't like some like super fancy Facebook, which is like the most ideal of all cases, you know. So what I've gathered here from what you've just told me is that your family would fail in Squid Game. That's what would happen. You know, if they're trying to cut out the shape, you know, from the Dalgona, from the little sugary treat that they got there, they're gonna fail pretty hard. Like, Noted. Your entire family is eliminated. You can't use a toothpick to save their life. Noted. Squid Game not for your family. All right. All right, let's get going here. Let's get started with this stuff. We got some intros to do. We got the section to do. Let's do this, ladies and gentlemen. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we are going to be continuing to move forward here in Chapter 8. We're going to finish up Chapter 8 here today, as it's only 2 sections. We're going to be doing Section 8.2. All right, that is what's going to be going on here for today. And so today, we're going to be looking at a slightly different perspective from what we looked at Section 8.1. Now, if you recall here in Section 8.1, we looked at seeing the normal distribution, we looked at normal CDF, we looked at inverse norm. The only thing that we effectively changed at the end of the day is we effectively changed the standard deviation when we were working over a particular sample size. Okay, so we're looking at a particular sample size. That's the perspective that we looked over, and we went ahead and made that one effective change. Again, taking the population standard deviation, dividing it by the square root of the sample size. Fine. That's what we went ahead and did last time here. Today, we're looking at a slightly different perspective. So we're looking at a slightly different perspective here. One that runs in similar veins from the last section here. It says, okay, we went to use normal CDF inverse norm. All right, but just from a different perspective here. Just from a different perspective. And that's essentially what we're going to be doing here today in Section 8.2. So let's go to the big board here, and let's see what we're looking at. All right. So, looking at the big board here for today, we're going to start off at question number 4 here from the handout. We did the first 3 questions here last time on Tuesday, so today we're going to start off with question 4. And so for what we're going to be doing and talking about here today, the perspective that we're looking over here today is going to be revolving around the idea of a proportion. So essentially, in this particular section, we're going to be, say, asking a question here that says, okay, a simple yes or no question, like, do you like brand A? So if you like, say, I like brand A, you would say yes. I don't like brand A, you would say no. And of course, we collect, you know, we ask a bunch of people, and then we collect the results of how many people said yes and how many people said no. All right, and that's essentially what we get here, and what we're going to be looking over is this proportion at the end of the day. And remember, the goal here is to, of course, take those results and extrapolate them to the general population in some form or fashion. In this case, we're going to be talking about probabilities in this instance. Ah, Court, my friend, how are you? I like whiskey. Me too. But maybe once in a blue moon. How you been, my friend? I hope things are going well for you, my man. I'm pretty good, dude. I'm pretty good. I can't complain. I cannot complain, Court. I cannot complain. Every day is amazing. Now, let's take a good look here. This is actually pretty cool, Court. You'll actually like this today. So let's take a look at question number 4 here. Question 4 says, how do we find the sample proportion / population proportion? All right, so we're going to be talking about proportions here today. So I want you to make note of the notation here that we have here on screen. All right, first and foremost here, the book likes to interchange these a lot, so we need to know what each of these notations actually mean at the end of the day. First of all, we have P. P here is the population proportion, meaning to say, if they've done a general study before and we say, hey, you know, what's the population proportion for people who like brand A, then that's the P value that we're going to get here. Then we have P hat, okay? Hey, how we doing, Gemma? Hope you're doing good, Gemma. Hello to you too. Then we have P hat. Now P hat here is equal to X over N. Now X is going to be the number of people who said yes to your question. Says, hey, I think that this is you know, I think I like brand A, for example, just whatever your question is. Out of N, which is the sample size here, which is how many people we actually surveyed in that problem. Okay. What you been up to lately, Gemma? Yeah, tell me. All right. So, what are going to be our big changes here? All right, our big changes here are going to be, once again, the standard deviation when we look at through this perspective here regarding proportions. So this is definitely one thing you need to write down here, and that is, what is the standard deviation of a sample proportion? So the notation here, we have the sample standard deviation here is going to equal, for a sample proportion, is going to equal the square root of P times 1 minus P divided by the square root of N. And again, be very careful about this standard deviation. Everything is located underneath this square root at the end of the day. So here we have the square root of the population proportion P times 1 minus the population proportion and divided by the sample size. So again, we're going to be very careful about how we enter this into the calculator. We're going to be very careful about what we'll need to write in. Again, we are using P here, the population proportion here. All right? Working and college work. That's what I'm talking about. Me too. Me too, Gemma. That's exactly what I'm doing right now. I'm working and college work. See, Gemma, you and I are the same. I just happen to, you know, work at college. Yeah. It just so happened I'm working at college. Okay, that's just what's happening. Okay, let's take a look here at number 6. How are we going to tie all this together from what we did last time? Let's talk about that. How do we tie all this together? So, what is the central limit theorem for proportions? Let's talk about that. All right. So, here's how it works. It says the larger n gets, the more the sample proportion will resemble a normal distribution. You just have to be smarter than me. I don't think that's true. I don't think that's true. I think everybody's smarter than some people in some ways. I will say that. You're better at me than a lot of other things that I can do that I can't do. So for example, I can't act. Okay, I'm not very good at acting. So you're very good at it. So, you know, there's always a balance there, Gemma, to be fair. All right, so basically what this means is that the larger amount of people that you ask this basic question to, the more and more it will resemble a normal distribution as opposed to just a regular sample distribution. So again, we wanted to make it look like a normal distribution so we can work on our tools of normal, CDF, and inverse norm. Those are the tools that we want to use. So more people we ask, the easier for us to actually see the predictability in the pattern, which will look more normal at the end of the day. Now, this is contingent on being very careful here. Now, the thing you have to be very careful about is asking enough people. Remember, asking 10 people their opinion about something isn't going to tell you squat, all right, about what the population thinks. What it is going to ask is, again, making sure that you have a large enough sample size where, again, you will get tangible results. So that's why we have this first condition here where we say, okay, well, NP times 1 minus P has to be bigger than or equal to 10. We just make sure that, again, we have a large enough sample size that we know we're going to get tangible, conclusive results. Now, we also get two other conclusions here. First and foremost, we have the sample mean proportion here is equal to the population mean proportion. So if we're going to make an assumption here, that assumption is that whatever our sample mean proportion here is going to be, all right, that's this notation with mu sub p hat, is equal to p. So we're just going to say whatever the population proportion is, we're going to make sure that we're going to use that same one when we actually ask people the question. So we assume that if 45% of people think that they like brand A, then we'll assume that whenever we ask, let's say, a bunch of people, let's say 1,000 people, 1,500 people, whatever, that 45% of them will also like brand A. Okay, so we need to make that assumption there. So we need a starting point, essentially. And then we make the adjustment here for the standard deviation, which was what we talked about above, which is the square root of p times 1 minus p over n. There. All right. So, lots of words, lots of talking. But you know what we got to do, ladies and gentlemen. Ladies and gentlemen, we have to do an example. We got to do actual numbers, okay? Me talking for a long time doesn't do anything. It does squat. So, let's look at an actual example. And let's put actual words and numbers and things. Let's do it. All right, so we're going to look at number 17. Let's do this together. All right, number 17. Marriage is obsolete. All right. According to a study done by the Pew Research Center, 39% of adult Americans believe that marriage is now obsolete. All right. Let's look at letter B. We're going to start with B here. What is the probability that in a random sample of 500 adult Americans, less than 38% believe that marriage is obsolete? So, we're given a sample size here, all right, of 500 people. Okay. This is actually a pretty interesting question. To find the probability of less than 38% think that marriage is obsolete. Now, I love this question for many reasons, because it does have large implications on reality. So, and people say math is not worth anything. I said this is one of those questions where you would say yes. Let me get a thing in the chat here. How many people? Yes or no? Simple yes or no. How many people think that marriage is obsolete? Is marriage kind of a useless concept? You tell me in the chat. Yes or no? Do you think marriage is obsolete? Divorce rate is higher than ever, so pretty useless, better not to be married. Okay, that's fair. Alright, Strolling says no. No, I don't think so. Okay. The concept, so Cord says yeah. Okay, now Anna says no. Anna says no. Alright. So let me ask you this question here, because I posited this question. My cousin is happy with her life with her boyfriend and son, and she's not married. Okay. Okay, well, you know, Bill, that'll lead me to my second question here. If you sign an agreement not to take all your stuff, it's alright. So if you sign the prenup, man. So let me ask you this question. I think maybe I'll know the answer from some of you here. So, and in relation to Bill and what Court said here, do you think that marriage is necessary? Do you think that marriage is necessary? Yeah, I figured for Bill you would say no. Okay, judging from what you said, but you said no. Okay. Amy says no. Anna says no. Court. No, I don't think you should define your happiness with that person. That's very fair statement to say, Maritza. I like that answer, Court. Now, let me ask. Okay. So, okay. May not be totally necessary to you, but. Alright, so let me ask you on a personal level here. For each one of you will have different opinions on this next question here. Would you personally want to be married in the future? Would you personally would like to get married in the future? Simple yes or no here. If they're rich. Court's like, I need to make sure I got the gold piece. So Sammy says yes, I'd like to get married. Marissa says yes. Okay. It's fair. Just as a personal question, be like, hey, do you want to get married in the future? Okay. I'm already married. That works. And it's like, I'm already good. I'm good to go. 5 kids. Yeah, if I didn't have kids. All right. So let me ask this way, because Anna's already married and stuff like that. And if you have kids and stuff, then that of course changes the question. But let's go back. Let's say you didn't have any children and you wanted to get married. Would you want to have children in the future? So, if you have kids already, I totally understand. But let's take that away from the equation here. If you don't have any kids, and let's say you wanted to get married, would you want to have children? Yeah, else I wouldn't get married. It's interesting to hear. It's not true that you get married just for having children, though, Court. Actually, it's actually ironic that that's not completely true these days. So, would you want to have kids? That's the question. If you didn't have children and you got married, would you want to have children? That's the question I'll posit to you guys. It's a simple yes or no, but I would want kids someday with or without marriage, okay. Yes, okay. That's fair. Everybody's got a preference, that's fine. There's a reason why I like this question, because this question has a lot of implications. So, like of all the examples I know in this textbook, this one has one of the most realistic implications that has far-reaching results. Yes, okay. Now, what's interesting about that is, all of you said yes, you want to have kids in the future. With or without a husband. That's fair. Of course. Because different society, different situation. I totally understand that. Now, the interesting part about this is, and I'll just point out my point of view, and that is, when I was in Japan many years ago, now it's nearly over a decade ago, I found pretty quickly that some Japanese didn't want to get married or didn't want to have kids, or if they were to get married, they would get married later and probably not have any children. A lot of times, it had to do with, say, financial freedom, or they didn't have enough money to raise a child. For example, they're working all the time, so they didn't have time. They had time to, of course, maybe maintain a marriage, but they didn't have time to maintain any children. I feel that a lot of people kind of find themselves in that situation today, where they're kind of working on a. Well, they have a lot of rules for the amount of kids in Japan. No, that was China, and China no longer has that rule. China used to be a one-child policy. Now it's a three-child policy. Lots of reasons behind that too. Actually, the big reason why, because they had a one-child policy, and that turned out to be a disaster. Japan does not have any limits. In fact, Japan tries to encourage couples to have children. They'll literally give them money for having children. They'll give them like $10,000 to have a child. Like, the government will literally give them, here's 10 grand, and we'll provide for the, if you have a kid or whatever, and that'll be great. So, but that's the interesting part there. The bad part is that not many people want to take them up on that offer. In fact, Japan and other countries are going through the idea, where not having kids, or even in some cases in Japan, I saw groups that were literally only for like friendship and not even marriage. They wouldn't even entertain the thought of marriage or even having any relationships at all. They didn't entertain a relationship, like they wouldn't enter into any marriage. They wouldn't even think about kids. That'd be the last thing on their mind. They would coalesce groups around this particular idea. I knew a lot of women over there would get married late, like in their 30s instead of their 20s. That would be pretty common over there at the time. It's really interesting that I see those same kind of parallels start to happen here a little bit, especially given our work culture. And I say, like I said, everybody's got an opinion about how they feel about having children or making a family and stuff like that. I totally understand that, but there is evidence to kind of support that here. In this case, so if I were to show you here, what is actually fairly interesting. Let me go to a map here. So if you were to look at the current rate of fertility, now this is from 2019, so this is a couple years back, but it does show a general trend. Replacement rate here for people, replacement rate for basically is going to be 2.1. So if you're going to grow in population, for example, the replacement rate for any given population is 2.1, as long as it is above the replacing the two parents that make it, that make a child, of course, then that will replace that generation, is essentially why the replacement rate is that not above 2.1. What is interesting is if you look at a country like Korea, like South Korea, they have less than 0.9, so you have less than one kid per woman in the entire country. So in fact, you're losing population at a very rapid rate in South Korea at this moment in time. A lot of that has to do with culture and attitudes, as kind of like what we're seeing now. Now, if you still don't believe me, even take a look. I'll go to Japan here. Japan is at 1.4, so you're still losing a lot of population here. In fact, Japan is set to lose a significant amount of population by the year 2040. I said by 2040 or 2050, I think maybe it'll go from like 120 to down to maybe 80 to 90 million. So it's quite a significant amount that could happen. Hey, Keisty. And if we look here in the United States, South. It's not so much the area. South Korea is a very well-developed country, like, for it to be fair. North should be south and south should be north. That doesn't make any sense. If we look at, actually, Keisty, it's actually ironic, Keisty. If we look at, let me see if I can find it here. Let's see here. Where are we? I need to. The United Kingdom, the UK is at 1.6. So, which is 1.6, right? And so 1.6 children per woman in the United Kingdom. So you are losing population in the United Kingdom. And the United States here is at 1.7, just a touch above that. Sam, my dude, you heard this is where you can learn about vectors? Yes. Yes, it is. In fact, the United States is a little bit of touch above the UK here. Find Canada. Let's see if I can find Canada here on this little chart. It's always interesting to see. Where is Canada? Canada is... Where are you? There you are. Canada is at 1.5. 1.5. Well, a lot of times, Keysty, it's really about general social attitude toward having children these days. It's actually fairly interesting, where people find it less of an incentive to have or raise children because of financial difficulties. Below normal average then of 2.1, that is correct. So Canada was also losing population as well. So you'll see a started decline of population in more developed countries than you do in obviously underdeveloped countries. And this is because of, like I said, the general attitude of how people look at having kids. It's like, I can't undertake, like, let's say you know, you're hard up for money, then you're, what are you gonna say? You're gonna say, guess what? I can't undertake a child. You know, it's just too much of an investment and too much time and too much energy when I can barely stay afloat myself. Or if you're in a relationship, your relationship's barely staying afloat financially or time-wise, so you're not going to be even thinking about that next step unless you're absolutely ready to do so, right? That's the first thing you have to think about. Yeah, who's the worst? As we said before here, South Korea. South Korea is the worst. They have less than one child per woman in the country. Yeah, developing countries tend to lose more population. So, our population has gone up a lot over immigration. Yeah, immigration is important for a country. This is true. Alright, Keysty, have a good one. Wonder if Sam's still in here. Yeah, so immigration does a lot for developing countries. It certainly does. It adds to that population over time. But yeah, attitudes change quite a bit depending on the country and depending on how well off it is. It's fairly interesting to see, and that's what this question actually pretty much provides. Is if you've got a cross section of the population here. Let's go back to our question here for just a moment. If you go back to our question here for just a moment, it asks if marriage is obsolete, and you would say 39% here, done by the research center. That's pretty high. You know, it's pretty high. You don't get that amount without having some attitudes change over time. Yeah, it's not 50%, but it would be much lower if it were, say, a different time frame. If we went back to, say, the 1940s, this certainly would be not even close to 39%. This would be like, you know, this would be like 10% even. So, you know, it's just a different outlook, different attitude, and different ways about how people look at that. Almost 50% of all marriages in the US will end in divorce or separation. Yeah, that's true. And what it does to that person after 50%, it's true. So, yeah, half of marriages end in divorce or separation. It happens. Like that's a possibility in every relationship. It's just how you actually view the concept of even being married in the first place these days. If if you're just turned off by the concept of getting divorced and having to go through all the legal paperwork, you're like saying, maybe that's just not a thing I want to do. Maybe we'd just be a couple. You're like, all right, that's it. That's fine. All right. I do have to do this problem here. I have to do some examples. All right. So now the real question is, ladies and gentlemen, how are we going to find this probability? We're going to be finding it less than 38% with this sample size of 500. Now, we do need to define our mean here. All right, so let's talk about our sample proportion mean, our sample mean here. Now, our sample mean is equal to our population proportion here. So sample mean proportion here, I guess I'll put. And we'll have a population proportion here as well. Now, that's going to be defined as our P here. What is our P equal to here? Let's divorce take all my cars. what is P equal to here, ladies and gentlemen? What is the population proportion here, based on this example here, in number 17? Where are we going to start off with? What do you think P is going to equal here in this case? Just give a guess in the chat, and then we'll talk it out. What is P equal to in this case? What is going to be our population proportion based on this question? What do you guys think? 500? I don't think 500 would be it. 500 here is the sample size. That's how many people we asked this question to. So we asked this question here. So 500 can't be it. P, remember, is going to be a percentage. Okay, so that's your hint here. P is a percentage. So P is going to be a percentage. So what percentage would that be here in this case? 38? Good guess. 62? Not quite either. Remember, we're talking about the probability of less than 38% here, but that's not quite it. 38% is not it. But good guess, guys. I would read the first part of the problem here very carefully. What does it say here? What does this first paragraph say? It says, according to a study done by the Research Center, 39% of adult Americans believe that marriage is now obsolete. Okay, so 39, right? 39%. Now, remember when we deal with percentages here in this class, right? That's the population proportion here. We asked a bunch of people, they asked, like, overall, they say 39% believe it's obsolete. Fine. Remember, when we deal with percentages, we always express it in a different way. How can we express 39%? Because I agree, 39% is the way to be. How do we express 39%? What number should we use to represent 39%? There we go. All right, good. Strolling, that's correct. All right. So 0.39 is correct. Very good. All right, so 39% we're going to use, again, is going to be our P here in this case. All right, now let's talk about what we're going to be using here next. Our probability is we still need to find it less than 38%. Now, we're going to be using our good old friend, what we talked about here last time, is normal CDF, okay? So that's going to be our guy here. Now, since we're dealing with percentages, okay? Now we're dealing with percentages, all right? We're not dealing with numbers here that are unusual. There are particular things, in this case, percentages. So the only percentages that we care about are going to be between 0% and 100%. Okay, those are the only two percentages that we care about, from 0% to 100%. Okay, so instead of doing kind of what we did here last time with, let's say, minus 1e to the 99, all right, and like, again, for minus infinity and positive infinity, we're only going to go between 0 and 1. So if I look at this here and I say, all right, I'm looking at the probability of less than 38%. Then essentially the numbers that I want to enter into the calculator here in this case, I'm going to enter in 0 here. I'm going to start at 0% and then go up to 38%. Okay. Then I'm going to put in my P here, which is my mean. That'll be the next number in here. And then we're going to put in our standard deviation. Now, remember how our standard deviation works. Let's go back to our handout here. We're going to have the square root. We're going to put in a bunch of numbers in here. Okay. So we're going to have the square root here of our mean, our P, 0.39, times 1 minus 0.39. And we'll divide that all by 500. We're going to take the square root of all of those guys. Okay? So that's what we want to be able to enter in the calculator. Now, what I want to do next with you guys here is I want everybody to get out their calculator for this. Okay, so please take out your calculator. All right, very important. All right. So if you have your calculator out in front of you, please type "got it" in the chat. All right, please type "got it" in the chat once you have your calculator out in front of you. We're going to do this part here together. So want to be able to get this, I want to be extra careful regarding this. So I want to be sure everybody knows how to enter this into the calculator. Hence why we're going to go a little slow over this part. Okay. Everybody's got it? All right. Okay, so first things first here. Let's put second and vars. Second vars. We'll go to normal CDF here. Okay, so we'll go to normal CDF here. All right. I'm going to delete all these tutors. Okay. I just need to show this up here. All right. All right, so for the lower here, we're going to go ahead and put 0. We'll put 0.38, and that's easy. And we'll put 0.39, and that's easy. So those first three numbers here, very, very simple. No problem. Easy peasy for everyone. Now, it's the standard deviation here that can be very tricky to enter. If you have a new school calculator, an old school calculator, it doesn't matter. What I'm going to type up here next is how you need to enter in the standard deviation, all right, in your calculator, okay? Because it can be a little tricky. And remember, the calculator is very particular about how it does order of operations. So that's why we need to be even more extra careful. All right. First things first here, we're going to go ahead and hit second and the square root. Okay, so everybody, new school, old school calculator should have something that looks exactly like this on their screen. All right, now we know what numbers we need to enter here. All right, it's right here on right below my face here. In purple, we know what numbers we need to enter in here. That's not the problem. What we need to do is format it correctly so it fits underneath the square root. So the first thing we're going to do here is we're going to hit another left parenthesis. Okay, so hit another left parenthesis. We're going to put 0.39. We'll hit the multiplication key. And now, once again, I want you to hit another left parenthesis. Next to that, we're going to hit 1 minus 0.39. Then we will close those parentheses there for 1 minus 0.39. And then we will close again another right parenthesis to close 0.39 times 1 minus 0.39. We want to make sure that those are multiplied together first. Then we hit the division key, and we hit 500. And then we close off that parenthesis. You have to make sure you close this off, by the way. So you have to hit the right parenthesis here. For old school calculators, at the very end, because you just have one line for normal CDF, make sure you add a second right parenthesis at the end so you know that that's the end of normal CDF. Otherwise, it could spit out the wrong answer here. So you need to be very careful about that. Okay, and then go ahead and hit paste. For new school calculators, you go ahead and hit paste. We'll see what we get. So if you notice here on my screen, if you did it right on the new school calculator, you notice this is all underneath the square root, which is what it should be here based on the formula that we're given. Okay. So if I hit enter here to figure it out, hopefully we get the right answer here, which is 0.3233. Okay, so please type yes in the chat if you got this exact answer. Please type yes in the chat if you got this exact answer. Then I know that you entered it in correctly. Fair enough. Court, you get a pass for just being awesome. Alright, Maritza, yes. Trolling, yes. Sanla, yes. Sammy, yes. Anna, yes. Bill, how about you? Were you able to get it? Just make sure everybody's on the same page here. If you're having trouble, Bill, just let me know. And I can re-show it here. Anybody trying to make a game soon, so taking coding. Oh, cool. Never touched anything before? Get ready. Get ready for some coding, man. You learn to code. Learn to code, Court. Bill, are you there? Oh, maybe Bill stepped out. I don't know. Alright, Bill maybe has stepped away. So, that's just fine. Alright. Okay, so, takes a lot of work. Takes a lot of work. Both are very good engines, though. Alright. Okay, very good. Let's move on to the next problem, then. So let's move on to the next part here. That's fine, that's fine. You're all good, my friend. You're all good. Alright. Let's look at letter B. Or letter C, sorry. What is the probability that in a random sample of 500 adult Americans between 40 and 45% believe that marriage is obsolete? So, probability of between 40 and 45%. Okay. So, can anybody tell me here what... I'm going to use normal CDF here, just like I did in the last problem. So let's just use normal CDF. Alright. So what numbers am I going to put into normal CDF? What numbers should I use for this example? Alright. What numbers should I plug in here for this particular example? Go ahead and type out those numbers there in the chat. What numbers should I use here for this example? What do you guys think? So between 40 and 45%. The percentages here. Alright, 0.4, 0.45, square root of 0.39. Alright, that's correct, Strolling, that's right. Alright, good. So 0.40, 0.45, that's right. And then we have the same two mean and standard deviation. Since the sample size never changed, that means the square root will not change as well. Alright, very good, Maritza. That is correct. I know what you meant there. Remember, square they have a couple missing numbers there, but I know what you meant there, Maritza. 0.4, 0.45, 0.39. That should say, you should have a square root in front of that. Square root of 0.39. And then 500. Don't forget 500 for our sample size here. Not 300, but 500. So just be a little careful about that last number there. All right. So let's plug that into the thing here. All right, so let's plug it in. Set second in vars. We'll go to the CDF function here. We'll try 0.40 and 0.45. Everything else will remain the same. See what we get here. So we get 0.3203. All right. Okay. Now, let's look at the next example here. Now, the next example I'm going to show off here is something that could easily appear on the homework as well. So let's take a look at that first. It says, would it be unusual for a random sample of 500 adult Americans to result in 210 or more who believe that marriage is obsolete? Okay, so let's give a quick question here before we start this problem. What does unusual mean? What kind of metric means unusual? What kind of metric means unusual? Less than 5%. Right, Strolling, that's correct. So we're going to use, of course, that metric at the end of the problem here. However, we need to be able to interpret what probability we're actually trying to find here. Okay? So it says, all right, we asked 500 people, is it unusual that says, okay, 210 or more of them said that marriage was obsolete? So here's what we got to figure out. Well, what's 210 out of 500? I got to figure that out here. Now, if you do this out on the calculator here, and it's not hard, all right, you'll find that 210 over 500 is equal to 0.42. Okay, that's what we have here. 210 out of 500 is 0.42. So in reality, what we're trying to find here is the probability of 0.42 or more. Okay, so essentially 42% or more is essentially what we're looking for here in this problem. And then what we want to see is that probability unusual, yes or no? Okay, that's essentially what we're asking here for this problem. So, once again, we're going to use normal CDF. Now, remember how this is going to work here. We got the same numbers as before with our sample size here. Again, our sample size here has not changed. It's still 500. So, if the sample size changes, we're going to adjust the standard deviation. But we don't need to in this problem. Okay, now the important part here is that we look at 42% or more. Now, as I mentioned here before, I'm going to guide you through this one here. Again, remember that is 42% or more, and we're only looking in between 0% and 100%. So because we're only looking between 0 and 1, essentially that's how we're going to write out what we need in the calculator here. We're going to write our lower value here being 0.42, and our upper value here being just 1. Okay, so from 4.42 to 1 representing 100%. Okay, and then the other two numbers here are exactly the same as they are before. And we divide that by 500. Okay, so let's go ahead and see what this probability is going to be at the end of the day. Let's see what we get. All right, so here, well, let's go second in vars. Go to normal CDF. We'll look at 0.42. We'll look at 1. We'll hit paste. And let's see what we get here. So in this instance, we get 0.0845. All right, good. All right, so 0.0845 is what we get here for this. So in this case, because we are asking if it's unusual, yes or no, and this is no, it's not unusual. So all right, so based on the metric here, it's not unusual here in this instance. All right. Any questions about that one? Any questions about this one here? Any questions? Any questions so far? Wahahaha. No questions? Okay. No? Alright. That's perfectly okay. Let's let's look at this. Alright. So let's look at another question. Let's look at the very next one here. Let's look at 18. Let's look at this is over the next couple pages. Next page, I should say. Be this in the next page. All right. Anyway, according to creditcard.com, 29% of adults do not own a credit card. All right. So 29% of adults do not own a credit card. All right. So we're going to answer just a couple parts here. So we'll skip around just a little bit. We're going to go to letter B. Letter B asks, what is the probability that in a random sample of 500 adults, more than 30% do not own a credit card? So here we're given a sample size of 500, right? And we're trying to find the probability that more than 30% do not own a credit card. So more than 30%. All right, first and foremost here, we need to establish a mean here. So we need to establish a P. So what does P equal to here in this case? What is P equal to? What is P equal to here in this problem? According to what we have. All right, very good, Strolling. That's right. 0.29. Nice. There's 29% of people who don't own a credit card, so our P here will be that decimal equivalent of 0.29. Great. Now, of course, the question is, how are we going to find this probability? Again, we're just going to use normal CDF. All right, what numbers are we going to plug in for this one? What numbers should we use for this problem? So we need the 4 numbers here for normal CDF. It's true. What numbers are we going to use for normal CDF here? What number should we use here for this problem? Should we use here? More than 30%. Alright. Okay, so Strolling, I will agree with the last 2 numbers. Ah, there we go, Sanla. Alright, so it says more... Alright, so just be careful there. Remember, the wording here means a lot. So that's why it's 0.3 for 30%, and then we go up to 100 here, since it's more than 30%. And then the last 2 numbers you have there are correct. We have 0.29, and then the square root of 0.29 times 1 minus 0.29. Divided by 500. Alright. So let's type this all out. Let's see what we get here for our probability. So just be a little careful about that wording there, and you'll have that. I know writing out that standard deviation is a little tough. Alright. Alright, so here we got 0.3 and 1. We're going to have 0.29. And then for this last one here, let's go ahead and clear this up. We'll hit square root. And then we'll open up those parentheses here. we'll get 0.29, multiplication button, another open parentheses, 1 minus 0.29, close parentheses, and then close parentheses again, divided by 500, and close parentheses. Okay. And we'll paste that on here. Let's see what we get here. We get 0.3111. Okay. So 0.311111 is what we get here for this problem. Okay, so hopefully you got this same answer that I did in this case. All right. Okay, so that's part B. Any questions about part B? Any questions about part B? Nope, hopefully that was pretty straightforward. And just want you to get comfortable with this idea. Okay. Okay. Let's look at the last part here, part D. Would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? Okay, so similar to the, not the previous example, but the one before that. Here we need to go ahead and figure out what 125 over 500 is. I don't know, anybody have that for me here? 125 over 500? What's that going to be? What's 125 divided by 500? What's that? .25. Okay, so we get 0.25. So what probability are we trying to find here? 0.25 is correct. What probability are we trying to find in this problem? Uh, 0.25 or less? Or 0.25 or more? 0.25 or more? Strolling, read that one more time. Gotta be careful about this, Strolling. Remember, it says sample of 500 adults to result in 125 or fewer. So be careful about that. There. Remember the wording here. One more time. So 125 or fewer here is what we have here. So we want to find the actual, actually it's the other way around here, 0.25 or less. Okay. Alright, so let's go ahead and do this one out here. We're going to do normal CDF. And again, if we're doing 0.25 or less, we're going to start at 0%, go up to 25% or 0.25, and the other two numbers here will remain the same. So nothing changes in terms of the last two numbers. The mean and standard deviation, since it's the same 500 people, or just 500 people in general, I should say. Alright, so let's enter this into the calculator and let's see what we get. And so we do second and bars. This, lower 0, upper 0.25, 0.29. Alright, good. See what we get. So here we get 0.025 2, 4, 4. Alright, so this is our probability here in this instance. So because this is less than 5%, then definitely yes, unusual. Okay. Alright, any questions about that problem there? Hopefully that makes it a bit easier to do. Alright. Any questions over this section? Any questions over section 8.2? This is on, as you get, what page in the textbook are these questions? For 413, 414. No problem, Strolling. No. All right. Very good job today, everybody. Very good job. Very nice. All right. So that will take care of section 8.2 here for today. Next time, everybody, next week, we are going to be going over chapter 9. Okay, so we're going to go over some new material here in chapter 9. But we're on a pretty good pace here so far to getting everything done. So, chapter 9 is what's moving on here next. We are going to be, once again, using the calculator next week. So don't forget to, of course, make sure you have that in front of you for next week, as we'll use that a little bit as well in the subsequent sections and chapters. All right. Okay, let's go to the baseboard. Okay. All right, so I want to thank everybody here for coming on out here to the stream once again. All of you are absolutely fantastic. All right, very, very nice job here today. I don't know why I don't have stuff showing, but okay. Man, Streamlabs is really weird today. I don't know, can't even explain why. Let me check that. That not working. Okay, fine. Okay, it's a thing. All right. Oh, any case. All right. In any case, ladies and gentlemen, thank you so much for coming on here to the stream once again. All of you are absolutely fantastic. I love all of you. All of you make this a wonderful class. I hope everybody has an absolutely wonderful evening and an absolutely wonderful weekend. All right, you know where to find me. I'm on here on Discord, or again, contact me via email if you're having issues. In the meantime, though, guys, I will be sending out an email here this weekend in regards to just notifying you and reminding you about the due date that's coming up here for your test for chapters 5 through 7. So remember, first priority should be finishing up the homework here for chapters 5 through 7, and also doing the test here for chapters 5 through 7, because that's due next Thursday at 11:59. So be sure to finish it up by then. All right? Thank you so much, everybody. And as always, thank you so much, everybody, again, very much. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right? Have yourself a wonderful weekend. Thank you all for coming on out. And we will see you next week, same time, same place. All right, everybody. Take care of yourselves. See you later. All right, everybody. Take care. Bye. Bye, everybody.